The next solution method we're looking at is the addition method. I've shown you this at least once, and I think many more times, in class during problem of the day time, and certainly if you're in math counts, but it's based on this idea. We know that, I don't know, this is just a random addition fact. If 3 plus 9 equals 12, and I don't know, say 4 plus 6, I could choose anything that's true. I could also use subtraction. But if 4 plus 6 is also equal to 10, if I add these terms, 3 plus 4 is 7, 9 plus 6 is 15, 12 plus 10 is 22, I will find out that I've also got a new equation that is also true. And I can use this fact very handily to deal with equations in two variables, certain types of equations. So if I know that 5x minus y is 12, and 3x plus y is equal to 4, I might not know what y is, but I know that negative y and positive y cancel out. And that leaves me conveniently with just one variable, 8x equals 16, which makes x equal to 2. I'm not finished until I plug it in. And when I plug it in, I get 3 times 2 plus y is equal to 4. 6 plus y equals 4. That makes y equal to negative 2. And as always, I must express as an ordered pair. So clearly that's a handy-dandy. Sometimes things might start out like 6x plus 7y is equal to negative 15, and 6x minus 2y is equal to 12. And at first glance, it might seem like we are able to use the addition method, but really, the 6x's are both positive right now, so that's not helpful. However, we've been doing equation work for a long time. We know that if we multiply this whole thing by negative 1, we're allowed to do that because we're doing it to all of the terms. And that gives negative 6x plus 2y is equal to negative 12. Now I can see that I have a positive 6x and a negative 6x. So when I add the new equations together, these cancel out. It leaves me with 9y is equal to negative 27, and therefore y is equal to negative 3. Of course, we're not finished until we plug it in. So if I say 6x plus 7 times negative 3 is equal to negative 15, I know that 6x minus 21 is equal to negative 15. And when I add 21, I see that 6x is equal to 6. And that means that x is 1, making the solution 1, negative 3. So the book does call it, when they don't cancel out in the beginning, they call it subtraction, because subtraction is, as we all know, adding the opposite. It is taking the opposite of all of these, and that's what we did here. There was a positive 6x, it became negative. There was a negative 2y, it became positive. There was a positive 12, and it became negative. Either way, the trick is looking and making sure that one of the variables cancels out, and if it doesn't, multiply one of the equations by negative 1. So let's look and say, I'm not going to do all of them, I'm just going to say 3x plus 2y equals 7, and 5x minus 2y is equal to 1. Does one of my variables cancel out? Yes, it does, because I've got a positive 2y and a negative 2y. So 8x equals 8, and I will leave the finish to you. However, if I say 3x plus 5y equals 10, and 3x plus y equals 2. As it stands, nothing cancels out. So we want to make all of these signs the opposite, because that means I've multiplied by -1. Now the x's cancel out. 5y minus y is 4y equals 8. So the first thing you need to do is make sure one of the variables will cancel out. If it doesn't, multiply one equation by -1. Then you just want to add the equations, solve the resulting equation, for one variable, plug that into either equation to find the other variable. And that's how you do it.